In question 1, we have got a biologist looking at the behaviour of bees and essentially is looking at what happens to the average number of wiggles as the distance from the beehive increases. And we're asked in part A then to find the covariance SDW. So in order to find this, we're just going to use the formula, which is sigma dW minus sigma d sigma w over n. And we can see from the information we're provided that sigma dw is going to be 13,833. We have got sigma w, which is going to be 33.6. So to find sigma d, you're just going to add up this row here, and you're going to get 1,960. So multiply those together, and then we can see here that there are 8 pieces of data, so we're going to take n as equal to 8. And if we complete that, we end up with an answer of 5,601, which is what we are supposed to. Part B, state giving a reason, which is the response variable. Well, you can see here that we're proactively looking at the distance, so we're deliberately choosing beehives that are set distances away, and we're seeing how the average number of wiggles changes. So this is the dependent variable, the response variable, because this is what we're interested in measuring. So we're changing the distance, or selecting beehives this distance away, and interested in if there's a relationship with the average number of wiggles. Part C is to find the product moment correlation coefficient, otherwise known as R, which is trying to assess the strength of any relationship between these two variables. And the formula for that, as you'll see from the formula book, there are quite a few, but the easiest one to use in this instance is the covariance Sxy over root Sxx Syy. And you will recall from part A that we have already found the covariance up here. So this is just going to be 5,601 divided by Sxx, which is going to be the independent variable here, which is d. So SDD is 394,600 multiplied by Syy, which is going to be here 80.481. And if we work that out, we get an answer of 0.994, which is a very strong relationship, given that the maximum value that R can take is 1, because the modulus of R is less than 1. In part D, we're asked to calculate the equation of the regression line of W on D. And we're asked to give our answer in the form W equals A plus BD. So just interpreting the equations for the regression coefficient, which is given as Y on X in the formula booklet, we can say that B is going to be the covariance over Sxx, and A is going to be Y bar, or the mean of Y minus B, multiplied by X bar. So we have already calculated the covariance in part A. So this is just going to be 5,601 over Sxx, which here is going to be SDD, 394,600. And that's going to give you a value for B of 0.0142. To find out A then, it's going to be Y bar, which here is going to be sigma W over n minus B over X bar, which would be sigma D over n. Again, this we already worked out previously, and we said that that was 1,960, and sigma W we've got here, so that's going to be 33.6. Both of those are over n, which is 8. And we've already calculated B here, so it's going to be minus 0.0142 multiplied by that. And if we work that out, that gives us an answer of 0.721. So substituting it back into this equation here, we're going to have W is equal to A, which is 0.721, plus B, which is 0.0142, multiplied by D. The final part of question 1 then asks us to use our regression equation here to estimate the average number of wiggles in the corresponding dance for 350 meters. So this should be fairly straightforward. All we're going to do here is just substitute 350 into our regression equation, which we've just worked out. And if we work that out, we should get an answer of 5.446. And then to round off, we're asked to comment on the reliability of your estimate, giving a reason. So essentially for this, you just need to recognise that the range of the data goes from 300 to 650 metres. So if we're making a prediction about anything inside this range from 350, we can say that that's going to be reliable, it's interpolation. But if, for instance, we had, I don't know, instead of 350, suppose this was 800, then obviously this would be outside of the range, therefore that would be extrapolation. So essentially here it's reliable because it's making a prediction about a number within the range of the data.